What we're going to be going over here is a linear programming example where we're going to be looking at shadow prices and slack variables and see how they're related to each other here, and really how they're related to sensitivity analysis. Okay, so what we're going to be dealing with here, we're going to have two different products that we're going to be manufacturing, product P and product Q, and they're going to demand certain resources here. They're going to have a number of labor units, and let's say on an hourly basis here, and then there's two materials, material A and material B, that they're going to be using, and then they're also going to be going through some machine C here. And they're going to demand here a certain number of units of each one of these resources that are being supplied here on a unit basis. Okay, so we don't really have to get into all those numbers here, but just to point that out, because this is what we're going to be using in our example here. And then one other thing, typically you'd be giving some cost on a per unit basis for each of the resources from labor through machining here. But we're not going to include those in our problem here because they may complicate our problem too much when we try to analyze it in terms of our shadow prices and slack variables. But they would normally have to be included. And then we also have for P and Q here, we're going to have certain sales price for each one of them. P, we're going to sell for $130 per unit, Q $160, and then we're going to have some resource availability that we'll look up above here when we set up our linear program. Okay, so the next thing here, let's just set up our linear program here. So what you're going to do is we're going to have an objective function here. We're going to just be maximizing sales dollars here. So we're going to have $130 here times whatever quantity we sell of product P plus $160 here for whatever quantity we sell of product Q here. And then I've got added in 0 coefficients for slack variables that we're going to be adding to our program. Okay, so that's our objective function here to maximize sales based on those unit prices for each of the different products. Okay, so now we have to look at our capacity constraints here. So what we'd have for our resources here, of course, I've got the labor, the materials for A and B here, and also that machining resource. But we also have some restrictions here on the product P and product Q here. For product P, that's 1P here, we can only sell up to 500 units. That's all we have market. We're predicting that's all we can sell in the market here. And then for product Q, we can only sell up to 800 units here. Okay, so what you're going to do here, you've got your supply here for each of those resources along with the restriction here on the sales for product P and product Q. So now you just look at your capacity constraints here, and I'm just lining everything up here for P, our demand here for product P and product Q. That comes right off the resource charts we have on a unit basis that we went over. And then we're going to be adding some, well, before we do that, then we have those constraints over here on our right hand side here. For labor is 4,250, that would be like hours here. And then material A and material B would be quantities here, 5,000 for material A, 1,850 here for material B. And then material C, we got, or machining C, we only got 4,600 hours. And then P and Q here, those were those demand constraints that we have. We can't sell more than those number of units. And in this case, our linear program be less than or equal to the resource that we have available here. Okay, so but what we're going to do here in this case is we're going to add in some slack variables here. And by doing that, it changes this inequality of less than or equal to an equal to here. So what we're going to do here, let's just look at the slack variables we're going to add. For labor, we're going to have S plus S1. And that's for labor here. For material A here would be plus S2 here. Material B would be plus S3 here. And then machining C here would be plus X4 here. But just see how we lined everything up here. For our demand, we have on a unit basis, and then we added in those slack variables here. So the key is here, why are we adding in these slack variables, and why are we adding them in as a plus quantity here? So the idea is when you add these slack variables, you'll be able to determine how much extra is available here when you run your linear program. That is, what is available here for each one of those resources, labor through the machining capacity here for each of those resources by adding in the slack variable here. So what we're really looking at, let's just look at in labors of these terms. Say P uses 3P plus 5Q here in labor, and let's just say that equals 3,000 hours here. Now, you see what's happened here. You've got by adding in those slack variables here, you're saying that that 3,000 hours here, that your demand for P and Q here, and you've got available, has to be equal to 4,250 hours here. Okay, so the slack is taken up by S1 here. So you know that 4,250, if you have 3,000 used here, that leaves you with 1,250 units here. So right away, you know you have an additional 1,250 hours here of labor. And the same thing for each one of the other variables here. And the reason we're adding the plus in here, again, because the left-hand side here, let's just say it is small. It's less than or equal to. So we know that the left-hand side, our demand here, is smaller than our supply here, only because it says less than or equal to here. And when it is smaller, that's where you're going to get your that extra amount that's available. Either you're going to have none available, or you're going to have some quantity would be available here if you don't use all of that resource here. So that's the idea why you would add in a plus or slack variable here. Now, the other case is here, say for example, you're going to add your labor here would have to be greater than your resource here. For whatever reason that is, our labor would have to be greater. So you just have a reverse inequality here, and you want to bring that back to an equal sign here. You want to set it equal to. So in that case here, what you're going to do is you're going to be subtracting out. Your slack variable would be a minus S, or it'd be a surplus variable if you have the greater than or equal equality to it. So you know you'd have, this one would always be bigger on this side here, larger here on your left hand side, and your right hand side would be smaller in that case. So in that case, you'd have to be subtracting. Being larger here, you'd have to take something away from your demand here in order that it equals the resource or the capacity that you have here, just to get that understanding. So we're adding in those slack variables so we can keep track of really what additional amount we aren't using here when we do our linear programming. Okay, so you get that understanding. Okay, so the next thing we want to do here, and we're going to advance on here just by looking at a shadow price, get an understanding what that is. So for each one of our constraints here where we have set it at equal to, we're going to look at for labor 4,250, what we would do for each to determine the benefit from an additional unit added here. So what you're going to do is just add an additional unit to each one of these. For labor, it'd be 4,251 here, material 5,000, move it up 1 unit, 5,001, and so on down here. And this is where we get what they call the shadow price or the due price. So what we look at it, we take the amount of sales in this case that we have, our objective function here, based on 4,250, the capacity constraint here 4,250, and solve for all of our other, the linear program would have solved here for whatever we value based on our equality here and our different constraints. And in this case, by increasing it to 4,251 units, we would have increased our objective function here, or we increased our sales by $32 here. So that's the benefit of an additional unit here, in this case a labor, that we've 1 unit or 1 more hour of labor, we would have returned here and increased our sales by $32 here. So that's what we're talking about, a shadow price or a dual price. Now if we went down here for all the other materials, A, B, and machining C here, we incremented those each by 1 unit here. We're going to get a shadow price of 0 here. And we'll look at why. And that means that we can increase these all day long here, but we're not going to get any increase in benefit for any additional units. So that's what, and I've done that in this case. So we're going to come up with a shadow price here of 0 here. Okay, so that's what we're going to be looking at here. Okay, so the next thing, let's just move over here and really quickly look at it. And we're only dealing with 2 different variables here, P and Q here, plus we have the different risk constraints for the labors and materials here. But we're doing this, and we can look at it just in 2 different products, and we can look at it in a 2D perspective here. So if we had P, Q, R, and S here, we couldn't look at it in terms of 2Ds or 2 different dimensions. We'd be really, we couldn't look at it. So that's why we're looking at those just 2 different materials. So just laying out our different constraints here. Those blue lines here, that was for Q here less than 800 units. Q I'm showing here on our vertical axis. P here is on our x-axis here. So just laying it out here in our constraints for Q, we had that blue line here. We can't sell more than 800. For P, what is it? It's less than 500, so we got to stay on this side here, 500 units. And then we got all these other constraints here for, and all you have to do in these case here is for, look at the case here with that 4,250, that was for our labor here. All you want to do is just set a P equal to 0, solve for Q based on what's available, 4,250, and that will give you whatever, Q, that will give you whatever Q intercept you'd have here, and then for P, just put Q at 0 and solve for P, and that's going to give you your P intercept here based on the quantities here. And then you can just draw those out here on your 2D graph here. Okay, so we've done that for each of those different constraints here. I've done that for the labor shown here, and then I've got the 5P plus 4Q here for the material A, less than 5,000, shown here in gold. And then in green, we got some machining capacity here, machine C, shown in this green, 3P plus 4Q, less than 4,600, shown here. And then we also have the material B here, 2P plus 1Q is less than 1,850. And those come right off our capacity constraints here in our linear programming. And we're just laying these out to understand those slack variables and those shadow variables here. So what I've done here, just laying this out here, you could visually solve your problem here to see where you come up against your constraints. So the green area here is really our feasible area here. And we come up against that labor constraint here. And we also come up against the sales here of P of 500 units. We didn't come up against any of these other constraints. And that's why if we go over here, we're going to get, because we came up against that labor constraint here, and by increasing one labor hour, we're going to increase our sales here by $32. But and that's a binding, what they would call a binding constraint here. But the non-binding constraints would be the material A, material B here, and then machining C. And those aren't, you can see where they aren't intersecting in our bound area here. They're above it. So that's why we're getting those zero here for our shadow price. We're not getting any benefit because we could increase those all day long here and it wouldn't affect what is going on here because we've got that constraint here on labor here. And then one other thing, this is dotted dashed line here. We're going to be going through those different graphs here. That's really just looking at sales. That 130P plus 160Q, that's the sales that we look at. And that is really just taking the slope of 160. We're increasing Q by 160 over 130 of P here, the increase here. And we're going to have a solution here of $153,000 here based on just going into the computer programming here. Okay, so now let's just go down and let's just expand on that here by, I guess we've got everything solved here. We're going to come up with this point. This is going to be our solution here because that is in our bounds area here. It's bound by the amount of labor that we have available here at 4,250 hours here, and then the sales P restricted to 500 units here. The answer is 500 and 550, and then where we have that restriction here in that bound, we checked our corners here, and we're going to come up with Q equal to 550 here. Okay, so we could have done this by mechanically by just putting it into our equations, doing our substitute, checking each one of those corners and so forth, but I did it. Typically, you'd be doing it with your linear programming. Okay, to expand on that, going down here and just looking at a magnified version of what we just did here. So you can see, here's our restraint here. Because we come up against that labor constraint, this red line that's going down, and then we have our sales, the blue line here for product P, and then product Q shown here. And that's where we had the intersecting. And you can see here that gold line here, that was for material A here. That hadn't come up, we hadn't bumped up against that. We're getting pretty close, and that's what we're going to look at in this example here. We're coming close to it. And then you can clearly see here material B and material C, and those green lines here are, again, away from our solution here because they're, in this case, they're not binding. There's no constraining and no constraining. They're not constraining our solution here because it's being constrained by the labor availability and then the sales of product P here, the maximum sales we can have on product P. So what we're doing is we're just saying that the material A here, material B here, and our machining C here are non-constraining, and that's why they have a shadow price. They offer, by increasing those, we have no benefit here, and they were what they refer to as non-binding. Again, there's no benefit for increasing those resources here because they are not restricting our solution. It's being restricted here by the labor dollars here. And that's where we get that benefit. That's if we add another unit here of labor, we're going to have that $32 benefit, and that's going to push that line out, and we'll look at it here. So we've got the shadow prices here of 0 for MA, MB, materials A and B, and MC here. And those were those slack variables, just to understand. S1 for labor, and that's why I lined them up here on our constraint chart, and we lined them up here so you can go back and you can reference that here. S1 through S4 here. All right, so that's that. So this was just going through the linear program that I have here. The solution was our sales. We come up with $153,000, and that is where we got that P at 500 and Q at 550. That was our optimal quantity here based on our restrictions that we have here. So what we want to look at is this S1 here, and that was our labor we have here. We have 0 slack here because we're using it all up. And if we added one more unit here, that increased our objective function, increased our sales by $32 here. So what you want to look at is, that's why we have that slack variable here, because that slack variable was really the additional amount we had available based on the equation that we have, or that our constraints that we have here. All right, so then if you looked at S2, that was what? That was our material A here. That was that gold line here. You can see you have slack here. We have 300 additional units here, or quantity of S2 here. And you can see that because it's not being constrained here. And then S3, we have 300 additional units, and S4, 900 additional units. S3 was what? That would have been a material B, and then machine C, MC here was S4 here. So that's really what you're looking at. You're seeing if you got any slack. Is the slack a plus here? Says you have an increase. And one thing I didn't mention, and I should have, when you do this program here, be sure to set your different variables. They have to be greater than or equal to 0 here. If I didn't do that, I should have mentioned that. I'm not sure here. But when you set up your linear program, be sure that you add in it for each of those variables, P, Q, labor, L, all those, your labor, your materials, and material A, material B, material C, make sure you have they're greater than or equal to. So the key is here, when you have that slack equal to 0 here, you're going to have some benefit if you increase the variable that you're looking at, or that in this case, that constraint that we have here. If you increase it, when you see it in your program here and you come up with a 0 amount, that's the case where you can look for an increase in your benefit by just increasing that by a unit here. But then where you see you get those slack variables here, the plus amounts here for material A, material B here, and machining C here, there you can see that there is no benefit, and right away you can make that relation. So that's where your shadow price is 0. You got a positive slack variable here. For that, whatever that constraint is, you should have a 0 shadow price. You got a slack variable equal to 0, then you should be able to check the benefit to see if you have, look at the on a per unit case here, the benefit you have. Okay, so now we'll just go on and we'll move on here, and we'll just look at really some sensitivity analysis here by looking at changing our slack variables. All right, now for our sensitivity analysis, and remember we had that labor with a shadow price here of $32. So what I've done here is I've increased the labor from 4,250 hours up to 5,080 hours, and now I know that's the benefit of the range, because beyond 5,080 hours I'm not going to get any extra benefit. Okay, so let's go and let's look at our graph here. So what we've done here, that labor line was sitting at 4,250 hours here. By increasing it to 5,080 hours, all I'm doing is paralleling it or pushing it up here from where it was to its new position here. And before we move on and look at that here, let's understand these different lines here. These lines that are sloping down here, those thinner black lines here, those are really the equal sales lines here. You can slide up and down these lines here, and they're really perpendicular to our sales slope that we have here. So you moving along these lines, you come up with some sales mix here between product P or product Q and product P here. So you come up with should have equal sales dollars. But we're really confined by our restrictions that we have here. So going back to this, our sales dollars here, we're sitting at 4250. We moved up to 5,080 hours here. So this is the case where we increased our sales dollars from $153,000 up to $174,800, and that was based on that we have a $26 per unit increase here. Now remember, our shadow price was sitting at $32, but we come up with an average unit increase here. For each hour we increased here in labor hours, we come up with $26 here. But we did change our product mix here. We were sitting with P was sitting at 500 hours. Now we've shifted down to 360 hours. It was sitting at its constrained time here, 500 hours. And then Q, whatever it was matching there, it was 550 hours. Now Q has moved up to 800 hours and P has moved down to 360. We just moved based on those constraints here, increasing our labor, we moved up and we come up against our sales constraint here for product Q at 800 max. But this is where that material A is going to come into play here. We're sitting at 5,000 units here in material A. So let's go and let's understand that. Okay, so moving over here, here's the case here where I just got it magnified a bit here. So I've moved that labor up from 4,250 to 5,080. You can see that here with the red line here for that labor. All I have is now I got this dashed line here. I just pushed it up here. That's all you're doing. By pushing it up here, you increase your sales here. But now this is where this material A, this is, you can start looking at all your constraints here. So you're coming, we bumped up against that maximum sales here for product Q of 800 here. That was the solution to that problem. And then, so we bumped up against that, but now we're sitting at our material constraint here at 5,080. That's as much as allowed. And then we have this this labor constraint here, 5,080, but then the material is sitting at 5,000. And you can see here, there's an intersection here. So let's understand that. All right, so if we go down here and look at, remember we were sitting with that shadow price on our labor at $32 here. Now when I moved it up to 5,080 here, adding another unit, 5,081, my shadow price come up to 0. So automatically by moving my labor up here, it's no longer, it's not a constraint here. It's a non-binding constraint at this point. What is binding is this new material constraint here. I'm sitting at 5,000 hours here or units in material, but I add that 5,001 units here, I'm going to get a $13 benefit in increasing my sales by that amount. So we've seen here, we had our inflection here where our labor hours here, we know is no longer a binding constraint. What is binding is the material. The material is taking over here. So that was those slack variables we can look at, our slack variables S1 through S4 here, and we'll look at those. Okay, so that's what that shadow price here, we've used up all our benefit here by increasing our labor to 5,080. Anything beyond that, we're not going to get any increase based on our constraints, but this is the case where this gold line here, that material constraint now comes into play. All right, so if we looked at our computer solution here, well, our sales moved up to 174,800. Then we had P at 360, Q at 800 that we looked at. But our slack variables, remember our labor S1 slack variable is sitting at 0 here now. We don't have any, we don't know, at this point, I know that I'm not going to benefit from it. But this is the S2 here, that material, that's also sitting at 0 here. That means we've used up all the capacity, all the availability we have here. All right, so this is where we're going to have that increase here and benefit by increasing our S2 here. S1 we know, or for our labor here, we know it's not going to work because I plugged it into the computer here and it didn't work. But then again, for material B and material C, which I didn't show here, you can see S3 and S4, there's plenty of slack here. We didn't use all the capacity or availability for either materials B or material C, sitting at 330 and 320 here. Okay, so now let's go and let's further do our sensitivity analysis here. Okay, so now we're going to have our labor. We're sitting at 5,080 hours here from 4,250. And our material, this is where we're going to increase it from 5,000 units here up to 5,365. And I know that's going to be the benefit range because I've got sitting here a shadow price here of $13, or an increase in our objective function, or increasing our sales here by $13 for each unit of material A that I increased from 5,000 to 5,365. Beyond that, I'm going to have a 0 increase here. All right, so going in, looking at our layout again here. Okay, this is what we're dealing with, that material A, we're moving from 5,000, and that's that gold line I'm showing you, that solid gold line. We're moving it to 5,365. And it was same as our labor here. All we're doing is we're pushing that line out here, and by doing that, we're increasing our sales. In this case, we moved from $174,800 here to maximum sales of $179,560 by increasing our material here from 5,000 units to 5,365. And again, that averaged out to $13 per unit, which represented our shadow price here. That was the benefit of range. So for each material unit we added, we increased our sales by $13 here. Okay, so everything else, the only thing that's changed here is, again, that sales line here, that slope of our line, where we were sitting up here, now it's moved down to here, and now we're bumping up again. If we looked at our sales quantities here, with this adding this amount of material here, we moved up to the case where P is now being, or our constraint is on our sales here of product P. I'm not showing the blue lines here, but it moves down up to 500 units. We're constrained by that, but our quantity Q here is moved from 800 down to 716 units. So we're not being constrained by product Q sales, but by product B. I'm not showing the lines in here, but nonetheless, you can look at it and you can just see our shift up here in material and what our benefit range was. Okay, so if we just go and magnify on that again over here. Okay, so here we're sitting. Now we're sitting, and we have to look at our new constraints here, because we're going to bump up against that. We know that we've exhausted our benefit here on material A by moving from 5,000 to 5,365, and I've done that. I've checked that solution. But this is the case we're going to come into. Again, we increased our sales. You can see it here from that solid gold line to our dashed gold line. But this is the case we're going to bump up against that labor. We increased our labor from 4,250 up to 5,080, but now this is going to come into play again here because we've changed our material, we changed our labor, and now our labor is going to become the new, we're going to have a new shadow price on that. So let's go and let's look at that. So we were sitting here when I had that, well, I had the $32, then I went down to 0, but now, since I increased my material here from from 5,000 to 5,365, I had that $13 benefit per unit here, but now when I check this new quantity here at 5,365 in my program, I'm going to come up with a shadow price here of 0 here. There's no additional benefit by increasing it to 5,365. But I did check my labor here at 5,080. I checked at 5,081, and I'm coming up with a new shadow price here of $15. So for each quantity of labor that I have, or increase an hour on labor, I should increase my sales by $15 here. So the shadow price here changes back to our labor. We had that material was our shadow price and our constraint. Now that we increased our material here, now we have to check for our new constraints here. And you can, just through our magnification, you can see it here. We come up again, just detailing it, we come up against the sales here of product P here, maximum of 500. We're below Q sales here. We were sitting at, and now 716. We're below it. But this is the case here where we have to go and we have to check that point here for both that material and our labor here, because they're all being constrained or restricted in this area, but we have to stick it into our program here. So that's all I'm saying is this is the case where we change back from the material back to our labor, and our labor should give us at $15 per unit for if we increase those units here. I didn't go beyond that, but that's how this works here. So if we've gone down here and just looked at that solution here, remember this is our solution, 79,560, then P was sitting here at sales of P 500, Q 716, but then we got those slack variables here for labor and material. They're both sitting here 0 for labor, so I know I should be checking that point here for labor, and I did, and I'm going to get a benefit here. But for material, I checked that here, and I'm not going to get a benefit by adding any other material here beyond what I already done. And then we're sitting here for both the material B, that was material A. Now we're sitting at material B and material C here. Again, I have plenty of slack in there, or I haven't used all the capacity or the availability here. Okay, so that's really how these programs work here. You have to be checking your at different points here. When you make one constraint change, then you have to look and see what your next constraints are, if they're binding or non-binding. When you talk about non-binding, that's where you're going to have this, in the relationship here is with that slack variable. How much non-binding, you should have some quantity available here, or plus quantity when you have non-binding. But then when it's binding or coming up against the straight, then you check your slack here to see if you've got any here. And you can see here, when you have a 0 slack or very little slack, then you should be checking to see if you come up against that constraint here. Okay, so that's how these slack variables work, and also those are, what do you call it, our shadow prices here, or our dual prices. Okay, so that'll end our discussion.